Welcome to lesson 8.4, Scientific Notation. So in this lesson, we're obviously going to be looking at the idea of scientific notation, and a number is written in scientific notation if it is in the form, and we use a lowercase c times 10 to the nth power. And the rule is that c has to be less than 10 and greater than or equal to 1. And then n, the power up here by 10, has to be an integer, meaning a positive or negative whole number, not anything that simplifies to a decimal. So what we want to keep in mind as we go through this, and what we'll be looking at, is that n, the power, will basically tell us how far we need to move the decimal point. If n is positive, we'll be moving the decimal point to the right. If it's negative, we'll move it to the left. And the key to remember about c is that it's between 1 and a number less than 10, meaning c has to be a single-digit number in front of the decimal. So if we look at these, we'll look at these first four examples, A, B, C, and D, to understand how to change scientific notation into decimal form. So they're giving us the scientific notation, and they want us to write it as a decimal. And again, the power will tell us how far to move our current decimal point. So if I have 2.834 multiplied by 10 to the second, I'm going to move the current decimal place 2 spots to the right, because this is the same thing as 2.834 being multiplied by 100. So that will give me 283.4. We just take the decimal 2 spots to the right. With B, 4.9 times 10 to the fifth. So what we're going to do is take the decimal on 4.9 and move it 5 spots to the right. And any spot where there's not currently a number becomes a 0. So that would become 490,000. In C, we have 7.8 times 10 to the negative third. So the decimal this time will be going left because it's a negative power, and it will go left 3 places. So 7.8 becomes 0.0078. And then in D, we have 1.52 multiplied by 10 to the negative 6. So our decimal on 1.52 goes 6 spots to the left. So it becomes 0.0000152. So example 1, how do we convert from scientific notation to decimal form? And what you want to keep in mind is generally where scientific notation is used is for numbers that are really large or really small. So in example 2, we're going from decimal or standard notation to scientific notation. So the rules here are we want to drop trailing zeros, meaning if a number ends in zeros, we get rid of those. And in the end, we can only have one digit before the decimal. So if I have 34,690, what I want to think about is only the 3 can be in front of the decimal. So this will become 3.469. And we don't have to write the final trailing 0. So the 34,690 becomes 3.469. And then we have to think, how far do we need to move the decimal back to be the original, which would be 4 places. So 34,690 in scientific notation, 3.469 times 10 to the fourth. If we have 1.78, we don't need to move the decimal at all. We don't have any zeros to drop. So if it's not going to move, it would be 1.78 times 10 to the 0 power. In B, we have 0.039. So to put this into scientific notation, I'd have to write this as 3.9, only one number in front of the decimal. And to move it back to where it was originally, the decimal point would go 2 spots left. So this would be 3.9 times 10 to the negative second. Now, 3 more to look at, D, E, and F. In D, we have 0.000722. So this would be rewritten as 7.22 times 10 to the negative fourth. Because if we think about 7.22, the decimal would have to go 1, 2, 3, 4 spots back to the original. In E, we have the thousands, millions, billions, trillions. So we have 5,600,000,000,000. So to rewrite that as a decimal, we'd get rid of all the, or as scientific notation, I should say, we get rid of all the trailing zeros here. So we drop the 8 zeros, and then we have 5.6 times 10 to the 9th. And then in F, we have 107,050,000. So we would rewrite that, getting rid of the 4 zeros at the end. Those are our trailing zeros. But we have to keep the other two in between the 107 and the 05, because those are not trailing zeros. Trailing zeros are just the ones at the end. So this would become 1.0705 times 10 to the 8th. And now, in example 3, we're going to look at how we evaluate expressions, writing the result in scientific notation. So what if we have scientific notation multiplied by scientific notation? Well, what we do is we take the numbers out in front. So in this case, 1.4 times 10 to the 4th, and that's being multiplied by 7.6 times 10 to the 3rd. We would do the 1.4 times 7.6 out in front, and then the other part would be 10 to the 4th times 10 to the 3rd. So 1.4 times 7.6 is 10.64. 10 to the 4th times 10 to the 3rd is 10 to the 7th. But 10.64 is not in scientific notation. I have 2 digits in front of the decimal. So this decimal would have to go 1 additional spot left, meaning this would be 1.064 times 10 to the 8th. So again, keep in mind, only 1 digit before the decimal point, so we had to adjust from this step to this step. In B, we have division. So we have 1.2 times 10 to the negative first divided by 4.8 times 10 to the negative fourth. So we set up both parts in division. 1.2 divided by 4.8 at the beginning, 10 to the negative first divided by 10 to the negative fourth. Well, both the 10 to the negative powers would flip sides of the fraction. So really what this is 1.2 over 4.8 times 10 to the fourth over 10 to the first. 1.2 divided by 4.8 is 0.25. 10 to the fourth over 10 to the first is 10 to the third. And then again, this is not in scientific notation. We need to get the 2 in front of the decimal. So because I'm going to move that decimal 1 spot right to get my final answer of 2.5, the 10 to the third becomes 10 to the fourth. And then in C, we have scientific notation to a power. So in this case, what we have is 4.0 times 10 to the negative second, all to the third power. So we do each part of the inside to the third power. So we'd have 4 to the third power, and then 10 to the negative second to the third power. So an exponent to an exponent, we multiply them. So we have 10 to the negative 6th power, and 4 to the third is 64. So we have 64 times 10 to the negative 6, but the decimal on 64, to be in scientific notation, needs to go between the 6 and the 4. So we'd be moving it one spot left currently. So the 10 to the negative 6 now becomes 10 to the negative 5th. So we have 6.4 times 10 to the negative 5th. And then our final example, example 4, the word scenario. It says in 1867, the United States purchased Alaska from Russia for $7.2 million. The total area of Alaska is about 3.78 times 10 to the 8th power acres. What is the price, or what was the price per acre? So what we want to think about is the price per acre is our total price divided by the number of acres. So our total price, 7.2 million, if we write 7.2 million in scientific notation, it's 7.2 times 10 to the 6th. So our total price divided by the number of acres, 3.78 times 10 to the 8th. That is going to be 7.2 divided by 3.78 times 10 to the negative 2nd. So that comes out to be approximately 0.019. And if we're rounding that to the nearest cent, that would be approximately 2 cents per acre. So going back to the beginning, the key to scientific notation is understanding it's in this form, c times 10 to the nth power, and the number c here has to be somewhere between 1 and less than 10, and n up here has to be a positive or negative whole number.